So current estimates for total U.S. electrical energy consumption is 4,137.1 terawatt hours per year. At what growth rate will energy consumption double every 10 years, assuming linear growth, exponential growth, and continuous exponential growth? So a little bit different than the last problem, but pretty similar. We're using the same initial value because it's for current values in the United States, and we just want to know, well, how big would the growth rate actually have to be if energy consumption was going to double in a 10-year period? So this time, instead of solving for the value of t, we're solving for a different value, the growth constants. So givens to do this are that we know that in each of the problems t is going to be 10 years. And we know that the initial quantity of energy that we're interested in doubling is equal to 4,137.1 terawatt hours. At what growth rate implies that what we're being asked to find is the growth rate constants for these different models. For the linear model, the growth rate constant is k, and then for both the exponential and continuous exponential, they're given the symbol alpha. We'll just call it exp and continuous. So that's what we're being asked to solve for. And now we're going to go ahead and apply our solution. So in the linear model, we know we need to start with the linear formula. Q is equal to Q0 plus KT. We're looking for doubling time, so that's saying 2Q0 is equal to Q0 plus KT. Can subtract Q0 from both sides. That's Q0 is equal to KT. And K is equal to Q0 over T, so that's just going to be 4,137.1 terawatt hours divided by 10 years. And that gives us a linear exponential growth, or linear growth constant of 413.71 terawatt hours per year if energy consumption is going to double in a 10-year period. In B, we're asked to apply the linear or the exponential growth model. I'm having trouble with my words here today. The exponential growth model is Q is equal to Q0 times 1 plus alpha raised to the T. So here we've got a doubling. So we can make that substitution there. We divide both sides by Q0. We're left with 2 is equal to 1 plus alpha raised to the T. We want to get alpha by itself, so we got to get rid of this T somehow. So we'll do that by using the natural log. So skipped a step there, but if you did the problem before this, you'd know what I'm doing. So now I want to get rid of this T, so it's a natural log of 2 over T is equal to the natural log of 1 plus alpha. Got a little bit of a math conundrum here. Alpha's inside a natural log, and that's what I'm trying to solve for. So if you remember, the natural number e undoes natural logs, so we need to take both sides, e to the whatever's on the right and the left side, so that's going to look like this, e raised to the power of the natural log of 2 divided by t. And then if I write it, it's going to be e to the natural log of 1 plus alpha. Sorry, I have a little bit of difficulty writing alphas on this tablet. There we go, that looks better. So on this side, I can't do any simplification there. On this side, the e undoes the natural log, so this just can be rewritten as e to the ln of 2 over t is equal to 1 plus alpha. And that allows me to solve for alpha as e to the natural log of 2 over t minus 1. We were asked for a 10-year doubling period, so that's e is equal to, or alpha is equal to e to the ln of 2 divided by 10 minus 1, and that gives us 7.177% per year as our as our exponential growth constant. We're asked again to repeat the problem for a continuous exponential, so similar but just a little bit different. Q is equal to Q0 e to the alpha t. 2Q0 is equal to Q0 e to the alpha t. 2 is equal to e to the alpha t. Natural log of 2 is equal to alpha t. Alpha is just equal to the natural log of 2 divided by t. So that's natural log 2 over 10. Make that look a little nicer. And that gives me 6.931% per year for the continuous exponential model. So it would, for it to double in the same amount of time, of course, the growth rate would have to be smaller since continuous exponential is a faster growth modeling. So that is problem 11.